In 1997, AB 82, which is also a calculator problem, we're asked if y is equal to 2x minus 8, then what is the minimum value of the product xy? Now, this is a problem, it's the only one in this particular packet, that foreshadows what we're going to call minimum maximum word problems or applied problems. And so quite simply for this, we start with a product xy. But because y is equal to 2x minus 8, we can rewrite that as x times the quantity 2x minus 8, which can also be multiplied out to give us 2x squared minus 8x. And we're looking for the minimum value of that. So what we really want to know is, where does this function change? What's the lowest point at which this function changes from decreasing to increasing? And you can see by looking at this function that it really is just a quadratic, right? And so this question could be answered without any calculus at all. It's a quadratic equation. If we factored out the 2x squared minus 8x, if we factored out 2x, we would have 2x times the quantity x minus 4, which means this parabola has zeros at x equals 0 and x equals 4. And since parabolas are symmetric about the line of symmetry, which passes through the vertex of the parabola. So over here to the right, I've drawn a parabola that passes through that has zeros at x equals 0 and x equals 4. Because that's symmetric, then the vertex will be at x equals 2. And so we know that the minimum value of that function has to lie at x equals 2. We plug that back into the original function. We know where the minimum value is, but to find out what the minimum value is, we need to plug back into the original function. And so I'm going to take a minute to write a note here. Where is a keyword that denotes an x value. What is a keyword that denotes a y value. And so you have to read each question very carefully, and in this case we're asked for what is the minimum value. We know that it occurs at x equals 2. We still have to plug that value back into the function, and when x is equal to 2, y is going to equal negative 4, and so x will equal, the product xy will equal negative 8. So this question was really tricky because 2 is one of the answers there, and I'm sure that a lot of students would have selected answer E for this one. But it asks what is the minimum value, and so the answer would have to be B. So we solved this entire problem using calculus concepts, but actually we did everything using skills and techniques from Algebra 2. The next thing that we want to do, though, is to look at how we would find this using calculus. And since we're looking for a minimum value, then that means that we would need to find the first derivative and find out where the first derivative changes from decreasing to increasing. So I'm going to take the derivative of 2x squared minus 8x, and that is 4x minus 8, or 4 times x minus 2, and we can see that that will be 0 whenever x is equal to 2. Sorry, not 0. Now since that's the only critical value there, we can probably assume there's no point on there that says there is no minimum value, so we can probably assume that, but we should really double check with a sign chart. So I'm going to take the value 1, and I get 1 minus 2 is negative. Negative times 4 is always going to be negative, so when I plug in 3, I get a positive value for x minus 2, and so that would be positive in that case. So that tells me the minimum occurs at x equals 2. I would still have to go and plug that back into the original function to get negative 8 and that final answer.